Hey scholars, it's me, Mr. I again. So Mr. McCaffrey just explained to you how to find the coefficients of basically of whenever you're trying to multiply binomials several times, right? So he gave you the first part of a piece of the binomial theorem on how to do this, which was, remember, n factorial over n minus r factorial times r factorial, which is basically what you guys did in example number 1. So we're going to go now, and we're actually going to use this. We're going to use this to actually expand this and see how it works. And remember, in the first video, you saw this already expanded, so you know what the answer is. But now we're going to show you how to arrive to that answer by using the binomial theorem. So here we go. First thing you know this is an exponent of 3. And we talked about this in the first video, which was, well, if the exponent is 3, how many terms are we supposed to end up with? We're going to end up with, how many? That's right, four terms, right? Remember, there's always one more term than your exponent. And we discussed that in the beginning, right? So let's go ahead and try to find our coefficients and see what we end up with. Remember that the way this is set up is n choose r, correct? Remember, n choose r, n being the exponent, r being the term, whichever term you're talking about, starting with 0, numbered on starting with 0, 1, 2, so on and so forth, depending on what we're doing. So let's go ahead and set these up for each of our coefficients. And like I said, we know we're going to have 4 terms because the exponent is 3. There's always one more term than your exponent. So here we go. So let's set up the first coefficient. My first coefficient is going to be my exponent, which is 3 choose the very first term. Remember, is not 1, it's going to be 0. We always start with 0. 3 choose 0. If I do this, this will give me my first coefficient. Okay? So we go over here and we say my second term then is going to be 3 choose what's after 0? 1, right? So my next one's going to be 3 choose 1. My next coefficient is going to be 3 choose 2. And last but not least, my last coefficient is going to be 3 choose 3. Okay? Now, I know I'm leaving a little space here because we're going to work with this and you'll see where we're going with this. So now, let's work each of them out individually, just like you guys did with Mr. McCaffrey in the previous example. So here we go. Let's work this one now. Okay, this one is 3 factorial over 3 minus r factorial, right? 3 minus r. Well, 3 minus 0 is, right, 3. So this is 3 factorial times r factorial. Well, in this case, r was 0. And then, remember, you guys know that 0 factorial is actually 1, right? So what happens? 3 factorial over 3 factorial is actually just 1, right? 1 over 1 is 1, right? So this actually happens to be just 1. Okay? Actually, I'm going to move this down a little bit right here, but that's what it was. This is 1. So now, let's do the work for this one. 3 factorial over 3 minus 1 factorial, right? Because this is n minus r, 3 minus 1, which is 2 factorial times r factorial. R factorial is 1. So here we go. If we work it out, we get 3 times 2 factorial. I stop right there because look what we have in the bottom. 2 factorial times 1 factorial, right? And this guy end up dividing out. And we end up with, well, we know 1 factorial is 1. 3 over 1, which is 3. So my coefficient for my next term is 3. Okay, let's do the same thing for this guy right here. So it's going to be 3 factorial over 3 minus r factorial, right? 3 minus 2. So it's going to be 1 factorial times r factorial, right? Which is 2 factorial in this case. So let's simplify this and see what we get. So we end up with, well, let me write this guy on the outside right there. But, well, I guess it doesn't really matter. So we end up with 3 times 2 factorial over the bottom, which is 2 factorial times 1. So these guys go away, and you end up with, oh, look at that, it's 3 again. Cool. And last but not least, 3 over 3, or, oops, 3 over 3, what the heck am I talking about? It's 3 choose 3, not 3 over 3. Mr. Zunza, what are you doing? Okay, so it's 3 factorial over 3 minus r factorial. So it's going to be n minus r factorial, which is 3 minus 3, which is 0 factorial. times r factorial. Well, what is r factorial? Oh, 3. Well, on this one, you're starting to see a pattern that if these numbers are the same, well, you'll see what happens. This ends up being 1, but we know that 0 factorial is 1, so we end up with a coefficient of 1 once again. So now, these are our coefficients. I know you're thinking, man, that looks like a lot of work. And you're right, that is a lot of work. But let's finish this up, and then we'll have a surprise for you afterwards. So, here we go. This is 1, 3, 3, and 1. So let's see what we have here. And remember, later on also, you can do all this craziness right here. It can be done in the calculator, and we'll show you how it's done later. But right now, you need to understand how it works. We just don't want you to be missing this knowledge of, like, how do they get these things? You need to practice this, because you need to know it, and then later on, we'll show you, some shortcuts you can take. But you need to be familiar with all this. So, here we go. Now, recall in the beginning, we talked about this specific example was written out here with others. And so now let's talk about the patterns that we discussed in video number 1 on how to come up with what goes in here, right? So here we go. Now, remember in the beginning we said, well, beginning with the variable on the left or the term on the left, whichever that was, you start using those same exponents and then you start going down by 1. The one on the left goes down by 1. The one on the right actually goes up from 0 and it goes up by 1. So let's go ahead and plug them in and see how this works out. So this is my first one. The exponent is third. So you know this is going to be x to the third. Well then we're going to go down by 1, right? So what's next over here? X to the second. What's next? X to the first. And then technically out here it's going to be x to the 0. But look, it's x to the 0. But we don't write it because we know that x to the 0 is what? 1, right? So that's why we don't really write it, but I mean, that's what's going on. So as you can see, it starts from wherever the exponent is, and it goes all the way down to 0. Okay? Now, let's talk about the second term now. The second term is basically the same thing, but it's actually going, instead of descending, is ascending, right? So it's going from the lowest to the biggest. Now, my second term happens to be a 1, right? So in this case, you're going to be like, well, 1 times anything is going to be times itself is going to be 1 every time. You're right, but this term will not always be a 1. So you need to be familiar with this. So if we go backwards, the 1, your first term starts with the 3. Well, the second term is going to start from 0, which is 1 to the 0 power. However, are we really going to write this? No, because you know that 1 to the 0 is always 1. But what's after 1 to the 0? 1 to the second. Not to the second, to the first. And then 1 to the second, and then 1 to the third power, right? Now, in this case, I'll put a dot right there so you don't confuse it with a 11. But, so now all we have to do, let's just simplify all these, and you'll see basically we'll end up with the final answer that we had in the beginning. So let's see what it is. So this is going to be 1, like we said, this is 1 to the 0, so it's just simply 1. So we get x to the third. Whatever this sign is, goes here, plus 3x squared, that's it, 3x squared, times 1. In the original example, you had a y here, so it would be times y. But since it's 1, it looks like it disappears, but it's just a 1. That's why. Plus 3x to the first, because 1 squared is just 1, plus, well, what is that? 1 times 1 to the third is 1. And that, my friends, right there is using your binomial theorem to expand this specific binomial. Like I said, is it a lot of work? Yes. Now you can imagine it's only going to get worse as the exponents get bigger and bigger, and as you add numbers here where you actually have to multiply. However, I promise you, we have a surprise for you. You're going to love our surprise because we're going to make this a whole lot easier. Have a good one.